Just a quick introduction. I'm Jerry, co-founder and CEO of Llama Index, and then I'll talk about what Llama Index is in the next slide. You might have known us as like a RAG company, especially from the open source days back when we started in 2023. Since then, we've evolved our messaging a little bit. And Llama Index, we think, is basically, we want to position it as the most accurate, secure, and easy to use way to build custom knowledge agents over your enterprise data. We're one of the leading developer platforms and communities for Gen AI. We're used by companies like Rakuten, KPMG, like Cemex, Salesforce, and more. All right, let's get started with just like some high level, like a macro perspective. We are really excited about agents, but actually specifically about this concept of knowledge agents. And so what we're really excited about is the fact that a lot of unstructured data has been locked up within different enterprise companies, within different data silos, in file formats like PDFs and PowerPoints. It's usually created by humans, shared by humans, and then also consumed by humans. So for the first time, LLMs have the capability to actually automatically inhale and just read all this information from unstructured data, and then use that to basically translate into insights and also action taking. And what we're really excited about isn't necessarily just RAG chatbot, but also like deeper knowledge automation. So I would characterize the last 2 years as people were building like simple RAG chatbots in production, just chat over any type of data. And the typical like orchestration algorithms you're using with LLMs would be quite simple. And the end result is that you basically give like a little bit of a glorified search engine to a knowledge worker for them to use, which is still useful. But I think really the opportunity here is to basically create these agentic workflows that can do multi-step reasoning analysis and in general lead to like greater efficiency gains for like basically knowledge workers in different fields. And so some of the form factors of what we're actually excited about include like document research, extraction, processing, and report generation. More on that in just a bit. I think if you think about some of the technical capabilities, I mentioned this, like a simple chatbot prototype might have like smaller scale data, simple user tasks, like not a super high accuracy bar. You might be asking very simple questions over the data, and it generally gives back the right result. I think what we're seeing the world evolve into is basically these more advanced agentic workflows that can read across diverse sources of data, actually take actions on it, do multi-step reasoning, chain of thought, and then also like some innovative UXs that are extensions beyond like the simple chatbot. And in terms of just two high-level categories or two high-level components of the stack that you might need to basically build these types of use cases. One is some sort of actually like a knowledge management layer, the ability to centralize, process, and parse all your data and make it available in a format so that LLM agents can access it. And then the second is, of course, like agent orchestration. We have an open source framework that we are defining as an agent framework. I'm sure you're familiar with like other agent frameworks out there too. But basically, there's like a set of tools, or you can just DIY yourself to basically build a set of different agentic workflows over your existing data to basically ship some of these use cases I mentioned on the right. Here is just like some high-level pain points that we've seen across both like developer teams throughout the enterprise, as well as like both from an individual developer level, as well as like team level. One is some of the pain points actually ship to production include like inaccurate data, and this leads to the garbage in, garbage out problem, where if you have like bad quality data, it's like your data is not parsed correctly, it's not indexed or stored, then it leads to your LLMs can't really reason over it, even if the LLM reasoning capabilities are very good. And this leads to bad end-to-end accuracy. There's also generally like a lack of consolidated agent architectures to build and ship some of these use cases. And especially once you get to the team level, especially we talk to some of these like very large traditional enterprises with just like generally a lot of people, but you start thinking about just organizationally, if you have a large Gen AI team, can you actually employ that developer team to ship multiple use cases very quickly and have a centralized architecture so that they can all build off of it instead of reinventing everything from scratch? This goes into kind of three high-level components of this talk, which is to build an advanced knowledge agent. First, I'll talk about like high-quality knowledge management and just that layer and what that means. We'll talk about some of the stuff that we have and then also things that are on the roadmap. Number two is agent orchestration and deployment, which is basically just a run through of how we think about orchestrating agent workflows, and then also how you can use that to build different types of applications. And then three is actually deep diving into certain use cases and walking through some example architectures to actually build these use cases. So to start with, we'll go into high quality knowledge management. If you've known us for basically the past year, you've seen that we're very passionate about unstructured data, and especially what we call complex documents. So a lot of documents can be classified as complex. They can have embedded tables, charts, images, and then they can have irregular layouts. They can have headers and footers, scans. Some tables that we've seen across earnings reports, forms, can basically just be really complex in nature, and actually just figuring out how to extract that in a way that's interpretable both by a human as well as a machine can be a pretty challenging problem. And I think we set our sights on actually tackling this first back when we first started working on some aspects of our commercial service. But basically, this is one of the first components of what I call a knowledge management layer. You need a good document parser, basically. And basically, you need a good document parser that can actually understand the content within the documents, enables you to then extract out structured information into a standardized schema. This needs to be robust across different document types, can handle, there's a long tail of different issues across most like human created file formats. And then also feed it into some sort of downstream workflows, whether you're trying to ETL it into Snowflake or you're trying to index it into a vector store. And this is just a high-level sketch of what we see as a knowledge management layer, connect to some source of data, do some parsing, extraction, and then also indexing. Maybe diverging from the slides just a little bit, I think especially with the advent of VLMs that can also do multimodal indexing and retrieval, there's an interesting kind of combination of both techniques that you can use where instead of just like parsing a document into text and then also feeding that through a text embedding model and putting into a vector store, you can also screenshot the page and then feed it through some sort of either image embedding model or some late interaction model, store that, and then put that into some storage system and do retrieval from it. You can do that. I think we actually do some of that in our commercial service too. And in fact, I think you probably do both. There's challenges to actually figuring out like the right fidelity of screenshots to actually take when you're dealing with documents of that complexity. But there's obviously a lot of interest in using multimodal LLMs for parsing and extraction. We have this service called Llama Parse. We launched it last Feb. There's companies that use it. This is part of the credits I think we gave you as part of this course. So that I think we gave everybody here some number of credits to use Llama Cloud, which includes the parsing capabilities. So if you have pretty complicated data, I would throw it at Llama Parse and see how it does. Here's just running through some example use cases with Llama Parse. And so one, this is a pretty basic example, but this is just running through an example like 10K document where, I'm going to go into this right here. Like this is just like the Apple financial filings, right? So if you go into an example of this PDF, you can see, I'm sure many of you have seen these types of docs, but there's a bunch of text, there's like charts right here. There's also like tables. And so what we do is we are able to the tables into well-structured markdown like this. And if you build a RAG pipeline over this type of data, we're actually able to give you back like the right answer, because LLMs generally have the ability to interpret markdown tables as long as they're formatted correctly. The issue with most off-the-shelf parsers is that they don't format them correctly. If you look at the baseline, this is where if you ask about like deferred state income tax, et cetera, like you get the wrong results in the baseline versus like the RAG pipeline that actually uses Llama Parse. Another basic example here is just being able to build like a multimodal RAG pipeline over like a slide deck. I'll run through the data in just a bit. In this example notebook, what we did was basically do this technique called contextual retrieval, which was a technique proposed by Anthropic. They popularized the name, but the core idea is very simple. All they do is for every chunk of a document, generate like a contextual summary that takes into account that chunk's positioning relative to the entire document. And in this case, we use Llama Parse or like the parsing module to actually process all the information within the slide deck into chunks per page. Even if you have like graphs and charts, you're actually able to process that into well-parsed text. Then you actually generate a contextual summary for every chunk of that page. What we do is after you generate like this text chunk for every page, you also screenshot the page. So you have both the text and image chunks. And then you like jointly link them together and create like some sort of embedding based off of that joint representation. So then during retrieval, you actually fetch both the text chunk as well as the image chunk, which is the screenshot of every page of the slide deck. And then you feed it to a multimodal LLM. And in general, like I think there will be more and more RAG pipelines where you're not only, again, generating a bunch of metadata on text, but you're actually combining it with an image representation of the page and using that to basically create more information content that the LLM can use to reason to better answer the question at hand. There's notebooks linked in all of these examples. I think if I go into this one right here, okay, this is the iconic report. Anyways, basically, I'll just go screenshot. You can see an example of a slide deck is basically this. It has a bar charts and you're dependent on some sort of like document parsing technology to actually process this in a way that's like ideally well formatted in a good reading order. So then you can feed it to any sort of LLM. And of course, screenshotting this page is also the way to basically maintain full information fidelity. And if you're uncertain about it, you could just do text parsing and then also screenshotting. In general, I think there's a certain set of use cases within certain industries that depend heavily on being able to use LLMs on top of really complicated data. I think some data types include just in general slide decks, which tend to be very visual in nature and have a lot of charts. Approach that we've consulted with other companies is being able to parse those documents into parse text, and then also being able to generate screenshots of those pages. Number two, being able to process common public filings like annual reports. Number three are Excel sheets, which I acknowledge. I think we have a basic version for this in Llama Parse, but it's still a work in progress. Excel is super complicated. I think it's basically some combination of a semi-structured 2D representation of something, but also you can have multiple tables for every sheet. They don't necessarily need to align in the same position. And it's something that we're dealing with as a problem, and hopefully we have some feature releases on that soon. But also forms, there's many different types of forms and questionnaires where you like fill in like a line or a box, and being able to parse that into a set of key values is also something that we do. This is just like a general algorithm to think about once you like figure out the parsing piece. And it's just like a simple algorithm you can use to basically do RAG indexing on top of any sort of complex document. So basically assume the PDF parser is pretty good and you actually get back like a decent representation of every text chunk of where the tables are on the page, where the images or diagrams are on the page. You can basically generate like an intermediate representation from every single one of these elements. So you can generate like an embedding. And there you can do that in a variety of ways. For text chunks, you just feed it to a text embedding model. For tables, you can also feed it to a text embedding model, or you can feed it to an LLM first to generate like a summary of the table, and then feed that to a text embedding model. For diagrams or images, you can use a multimodal LLM to generate an image caption, or directly use like an image embedding model that's aligned with the same embedding space as the text model. And so basically then you end up with a bunch of embedding representations, and then you index those. And then during retrieval, you obviously retrieve those embedding representations, and then you reference it back to the source element. I think in general, we see a lot of RAG pipelines becoming a little bit more multimodal in nature as these capabilities improve. So like the elements you're dealing with during synthesis are actually not just text, but some combination of text and also images. Cool. So that was like on the knowledge management piece. I think in general, especially for this class, you have access to Llama Cloud and especially the parsing capabilities. So I just play around with it and yeah, open to any feedback and questions. And hopefully it actually helps you build some sort of pipelines over complicated data. The next piece is agent orchestration and deployment. And so now that you have your data processed and set up, how do we think about like building agentic flows over that data? One concept that we basically came up with is this idea of what's an extension beyond RAG? And we just called it like agentic RAG, which is you have a RAG pipeline where inherently it doesn't actually do reasoning. You just feed data to a vector store, and you're mostly using the LLM to synthesize the information from the vector store to generate a result. If instead you treat the vector database as like a tool that an LLM can call through an API interface, and then you combine that with a set of other tools that the LLM can also call. Some of these other tools I'm sure you're familiar with, they include like structured data, like SQL databases. They include like web search. They include just like generic actions of a calculator or something that you might encode in a function. Then you can separate like what the responsibility of the tool is with some sort of like higher level agent reasoning or planning layer. And so the concept of an agent isn't necessarily like super well defined, but there's just like some general patterns that people have come up with in that like agent planning layer. This includes some sort of like general orchestration of how that agent reasons through things. I'll walk through how we think about those reasoning workflows in a bit. But yeah, there's some ability to iterate through the set of actions to take. There's also some sort of memory or state management. And of course, there's the ability to do function calling to actually call some of these tools through an API. But if you think about going back to the previous section, the knowledge management piece is really structuring your data in the right format. And then the goal is to basically create a set of really nice tools for an agent to then use. Then the agent is basically like the orchestration or planning layer on top of these tools that can solve different tasks. We have a pretty flexible definition of what an agent is. And for us, it's really less about a single definition of an agent and more just about something that's like a little bit more agentic versus less agentic. Less agentic flows are things where, as a computer program, you're basically defining it with a lot of constraints. But you're defining the if statements and while loops and conditionals and the overall control flow of the program. And you're maybe using the LLM to make certain decisions throughout that flow, but definitely not all the decisions. So here is just an example where maybe you have an LLM-powered router that decides between two tools, but the overall flow is that everything will run to completion. There's like a roughly linear sequence of steps, and there's not too much like branching or other logic going on. And so you basically have some sort of guarantee that it will complete within a certain number of steps. And then you have like unconstrained flows where you basically, this is just the pattern of a general orchestrator agent with a ton of tools, but doing like a function calling or a React loop. And then you're both like giving the agent control over what tools to call at every step, and also giving it the control of like how long to actually run for until completion. And in that sense, you're like giving up like human control of the program and really letting the agent decide for itself. There are certain benefits to this type of approach, and that it's actually pretty general. If you just think about a general reasoning model, it has access to a set of tools. It can basically just figure out what to do on any new task. And so it can generalize to more different types of inputs. But of course, there's concerns around like guardrails, and it can be less reliable. I do think over time, as like reasoning models get better, context windows get bigger and they get cheaper, there will be consolidation of agentic architectures. So that actually probably goes a little bit more into this space versus defining like super custom workflows in certain settings. Though, of course, there will be like space for both. And I think one of the core areas of investment for us, besides like everything on the knowledge management piece, is actually agent orchestration. We basically have evolved the open source framework into something that enables you to basically build agentic workflows at different levels of abstraction. I'll run through, I think, some basic examples, but at a high level, it's basically like an event-driven system where you can decompose any sort of agentic program as a series of steps. Every step can listen to some sort of input events that come in. You write the logic within the step. So if it makes LLM calls, if it does some sort of conditional logic or reasoning, or if it's just like regular Python code. And then you decide what output event to emit. And then you can, of course, compose different workflows together. You can piece together granular workflows into higher level workflows. You have the full flexibility at the base level to write whatever code you want. And it integrates with some of the leading observability tools like weights and biases, Rise, and MLflow, and so on and so forth. And then we're also working on ways to enable you to deploy that into a production service. And the overall flow of how we see building an application is you compose a workflow using Llama Index workflows with some of the core components. We have this additional project that we're iterating to make more production ready called Llama Deploy, where once you set up these event-driven workflows, you can actually deploy them as a set of microservices. They have full support for human in the loop, state management, and also the ability to like execute an async, and then translating that into a full stack application template. Here, I know maybe this isn't the best screenshot, but I basically tried to give you a sense of what it's like to actually build a workflow from scratch. I think maybe a better example is I'm just going to go into this web link right here, where in general, the way a workflow works is you can just define like a Python class. It has a series of steps. Every step can listen to an input event, emit like an output event. And then here you can basically write whatever logic you want within the step. So it's a pretty core layer of orchestration. If you're familiar with like temporal, or I guess like Airflow, it's not that dissimilar from it, but instead of like a graph-based approach, this is very much like event-driven. And the benefits there is that you actually don't have to define a bunch of edges in the graph. You can just write all the orchestration logic in every step and then just choose which events to emit. So basically the edges are implicit in the code that you actually write within every step. This is just like a starter tutorial. So obviously this is like very basic. This example right here is how you actually build like a full React agent. So a React agent flow is something where you define a series of steps. It takes in a message, does the React prompt to basically do chain of thought on the input, figure out what tool to call, and then it actually passes a message back to the beginning to basically create a loop of reasoning until it decides that it's actually complete. So this is basically an example of how you actually build a full React agent from scratch. And it's also in our docs. We started off with that base abstraction just because I think that is like a pretty nice like core layer for people to get started. We also, I think, started to recognize the need that folks have where there are certain agent patterns that are emerging where, and oftentimes for certain use cases, you might not really care about rewriting everything from scratch. And so we're just going to create like some sort of higher level layer of abstraction that makes it a little bit easier to think about an agent as just like a unit instead of you having to redefine the Python class. And then this is actually like a higher layer, higher workflow abstraction on top of the core workflow stuff. And this is basically like our multi-agent like orchestrator. So the way it works is it's actually very simple. It might be similar to some other frameworks that you're familiar with, but basically you have an agent workflow. This is the definition that we use, and it's our multi-agent orchestrator. You can define a set of functions, give them to an existing agent. So calculator agent, retriever agent. And then you basically just, instead of you having to figure out how they communicate with each other, you just give it to this agent workflow, and then the agent workflow will figure it out. So you trade off probably a little bit of latency and control for just ease of use, and also the ability to dynamically process different inputs. The request is routed to like the root agent. There's some master agent. It can then delegate a task to an existing sub agent, like one of these agents that are described right here. One agent can decide to actually directly hand off the task to another agent instead of going back to the orchestrator. And then whenever the task is fully complete, the final response is returned to the user. And so basically, you just give it to a pack of agents, let it figure it out, and then we give you back the final response. That's some of the overview on the agent tooling that we have. And now to put it together, we will talk about just like 3 core architectures and actually around like knowledge agent use cases. And so I think a general theme probably throughout this course is just like, how do you build stuff that's more agentic beyond the simple RAG chatbot? And for us, again, the 3 core use cases are document research, extraction processing, and report generation. I'll start with document research. I think this is something that is basically just like the agentic RAG chatbot, but instead of being able to only answer simple questions, it can do multi-step research over your documents, pull in the right context to answer the user query. There's a few elements of like agentic RAG patterns that we find actually useful in building something a little bit more sophisticated than basic RAG. More on that in just a bit. But some of the use cases that we see, especially both among users and customers, include like being able to do financial due diligence over different types of documents, product documentation search, being able to have a search assistant for regulation compliance, and also customer support and operations. Here's just like an example workflow of building like a research assistant that does a little bit more things than like a naive RAG chatbot. Specifically, one thing that we found to be relatively useful is to not just be able to retrieve like specific chunks, but actually retrieve entire documents. The reason is depending on the nature of the question, some questions actually do require access to the entire document as context. Whereas some questions are pointed enough in that you can basically find that answer in specific chunks. And so I think there's a set of different notebooks in the advanced RAG category that basically deal with handling these different types of questions. In this example, what we do is we process the user query, do chain of thought on the user query to break it down into smaller subtasks. And then within a subquery, we have a router that depends whether to basically do document level retrieval or chunk level retrieval, depending on the properties of the query. To make that router really good, what helps is basically a few shot examples of both existing queries that have worked, as well as like snippets from the source data, so that the LLM has enough context to reason about how much information it actually needs to help answer the question. And then once it feeds it to one of these two retrievers, then it can try to either return specific chunks or like the entire document to synthesize the results and get back a response. The second use case here is report generation, which I think you guys have talked about, but part of this idea is that instead of just getting back like a chat response, actually using an agent to generate like an entire artifact. Part of that, just like intuitively from a use case perspective, you're like a knowledge worker, you're like typing on your computer with ChatGPT, you're still responsible for not only figuring out the right inputs to ask ChatGPT, but then translating the outputs into the final thing you're actually creating. So what if the agent can just do that final thing you're creating end to end? And that's really the direction that report generation is going for. It can be actually relatively domain specific. It could generate like a document. For instance, in healthcare, it could be like a clinical progress report of a patient. In engineering and product, it could be like generating a PRD. It could be generating like an RFP response. But it could also include like filling out an Excel spreadsheet. It could include filling out like a questionnaire and just making sure that you're able to, ingest a set of context and then like output that data in some sort of structured way that fulfills like a task. We have a set of example agent architectures that enable you to basically build or get started building a set of different report generation use cases. And again, I think this somewhat depends on some of the core capabilities around parsing, extraction, and then also building the right agentic workflows on top. The first is multimodal report generation. What if you could generate a research report that both includes like text, but also cites like certain diagrams and images from the source document? And there are some examples here where we leverage the parsing capabilities to make sure you extract out the right text from the source document so that you have the right context to write a research report. But you also need image extraction capabilities so you can cite specific images or charts within that source document. And then the overall architecture is something like a researcher writer setup, where you basically have a researcher workflow that is responsible for retrieving the relevant chunks and documents, and then the writer that can use the researched data to then synthesize the final answer. There's ways you can, of course, make this more complicated with like human in the loop and also have a reviewer self-reflection step, but this is just like a way for you to get started. Another kind of interesting use case that we're working on with some customers is basically RFP response generation. So being able to actually generate a response that adheres to like guidelines outlined in an RFP. So first, you need some sort of parsing extraction algorithm to read like an RFP document and then parse out some of the core requirements, translate those requirements into a set of questions. You can basically do some sort of like structured output extraction to extract out some of the core clauses from these documents, get back like some answers. And then for each of these questions in this notebook, you can break it down, try to look up information from a knowledge base to try to answer those questions, do some human in the loop verification, aggregate all the QA pairs, and then generate a final response. There's some other use cases too, which are interesting, just being able to fill out like an Excel spreadsheet. I think some of the patterns are similar, given some sort of input, like process the stuff that you need to fill out, look up things in a knowledge base, get that information, and then fill out like the final spreadsheet. This is something that could be relevant in like finance, could be relevant in basically any industry that requires like outputs and a bit more of a structured representation. And then I think the last category, which honestly is pretty related to some of the stuff I talked about, is basically just like more general architectures that can automate like document workflows. I think when we think about like certain use cases here, we think about basically like a generalization of an entire industry that's centered around like document processing and extraction. So if you think about like an invoice processing software, that's an example of something that we think LLMs are just going to totally transform. But like for the first time, instead of crafting very like hand-tuned heuristic algorithms for domain-specific documents, you can actually just create general agentic architectures, assuming you have the right pieces in place that can just automate an entire business process from existing data. So some of the use cases include like invoice processing, being able to extract out like line items in a standardized format, put it into some downstream system, like contract review, being able to, given a legal document, the equivalent of just like throwing it into ChatGPT, but actually grounding it in your own company's like regulations and procedures, being able to like process insurance claims in an automated fashion and more. And so like a lot of, I would say, administrative or back office operations teams across IT, legal, and more basically deal with certain types of operational work that can definitely be accelerated with kind of high accuracy AI agents. An example here is basically like contract review, given some sort of like vendor agreement, make sure you can actually process, extract it correctly, do some sort of extraction to look at like the key terms, for instance, in the MSA, and then ground it against your own both company and also public regulations and guidelines. This is where retrieval comes in. And you have a knowledge base that's indexed. Maybe you also have a structured database. You have an agent that can look up knowledge from your knowledge base, pull back the right information, and then generate like a final structured output to determine whether or not it's actually compliant. You can see through a lot of these patterns where if you think about RAG as just retrieval plus like synthesis, retrieval is still like a big thing in all of these types of agent workflows, but it's just like one step in a multi-step process. And so to some extent, a lot of these are basically just like generalizations of what a RAG chatbot is. That's basically it. I'm happy to share the slides. There's like kind of links to some of these notebooks there, and then happy to go more in detail on any of this, but also I can leave time for questions.
Yeah, I think I have a link to the slides, so I'll just share them in the notes as we publish these videos. Are you able to see the Slido event? Otherwise, I can just read out the questions one by one. Cool. I guess the first question is, I think a lot of people want to answer this question. What are your thoughts on the best methods to map relationships across multiple sources and files? I think a lot of time, like
Yeah,
traversal is an issue.
Yeah, that's a good question. To some extent, I haven't actually. I think there's like certain techniques we use already, but I think general like construction of a knowledge graph ontology is something that I haven't actually thought super deeply about yet. And maybe this doesn't quite answer your question, but I do think this is one example of something that's a pretty popular use case. So give me one sec, trying to find. We recently refactored our repo, so I'm trying to go into this right here. This is an example of a notebook where it's not inter documents, so it's not like mapping out relationships between documents, but a popular request is to actually figure out like the right section hierarchy within a document. And assuming you first just have the parse text within a document, you can go through every single page and basically extract out if that page contains like a section heading, store that as like metadata within each chunk. So then during retrieval, if you wanted to retrieve like contiguous sections, you can basically do a first pass retrieval to just do vector search on relevant chunks. And then from there, use metadata filtering to actually do a second retrieval pass to basically try to retrieve adjacent chunks nearby that form a contiguous section. And that's actually an example of almost like how you can simulate like a graph rag like algorithm to return like an entire like contiguous chunk. I think the answer to some of these questions around like mapping relationships across sources probably comes down to some sort of like metadata standardization and then and tagging and then being able to retrieve that in a contiguous fashion.
Sweet. The second question is about evaluation. So how can you talk a little bit about how your platform evaluates agents and tools performance and handles errors in particular?
Yeah, it's a popular question. To be honest, we intentionally did not build an eval observability tool. We do integrate with a lot of great partners that I can refer you guys, again, weights and biases, length views, like Databricks, et cetera. I think it's like a hard problem. I think I don't have unique insights into it, and I'm sure all these like eval providers probably have more. I think some of the core things you basically need to do is to like the general recommendation I have is just build the end-to-end use case, evaluate that first before trying to break it down into subcomponents. It's typically just a little bit quicker to iterate if you just build the end-to-end thing first. And then in terms of like how you actually measure the end-to-end thing, the first thing you do is just have an Excel spreadsheet with 20 inputs and then just eyeball the results. And then you can figure out LLM-based evals after.
The second question is one I asked, which
Yeah.
is how do you think about ingesting data over time? I think a lot of times, a lot of the folks here have issues where data documents are changing, documents are growing,
Yeah.
things are being updated. Could you talk a little bit more about that?
Yeah, for sure. So there's actually two things. I think the first thing that we do, and this is like the data pipeline issue, the most common data pipeline issue is like when you do updates, you don't want to reindex the entire files. And so you basically just, what we do is, especially in Llama Cloud, like our commercial service, we store like the hashes of the documents so that upon reindexing, you can see if there's any files that have actually changed. If they have shifted, then you basically just make sure that you propagate like the updates and deletions. I think that's step one. Step two is sometimes there's like issues with permissioning. And I think that's something that I think everyone can build if you had enough time. It's just annoying to build. But for instance, like the permissions on the document can change. And I think one thing there is oftentimes one, when the permissions on the document changes, like for instance, in Google Drive or SharePoint, then you oftentimes want that to propagate immediately instead of on a batch setting. Number two is you also don't want to necessarily reindex the document because the content itself didn't change. It's just the permissions. So you basically need a way to separate the metadata that actually like changes the semantics of the document and then metadata that doesn't affect it. And so if you can separate the two, then you can just propagate updates to the metadata without having to reindex like the source.
Oh, I'd never even thought about this example where like permissions are changing and things actually need to update in real time. So it gets
That's
there,
a
you're just like updating SQL or
yeah.
updating something in like Dynamo.
Yeah, exactly. You almost need like a separate data model for it. It's actually annoying to build out because you also need to integrate with the data sources for
Yeah,
every data source that you connect to. So it's actually an interesting problem because I think every enterprise company deals with this.
nice. This is a question that I just get asked a bunch, and so I'm really curious what your answer is. But what are
Mhm.
your thoughts on long context of a RAG? I think most of the students here definitely already have an opinion, but I'm curious to hear an answer from you.
I think if you have 5 to 10 documents, you can just stuff it into ChatGPT. I do it. I just use I and I'm an active user. I pay the $200 a month for O3 and I copy and paste a bunch of text and then I try to get back the results. I think what we're dealing with is basically just like your knowledge bases where it just doesn't really make sense to upload like a million documents into the context window anyways for a variety of different reasons. And also the UX like form factor isn't there. So I
Mhm.
think for us, it's really long context windows, fantastic. It's great. You can actually use it to do more things. We want to use that to index like larger volumes of data.
That makes sense. I almost feel like your answer here almost points to the fact that maybe for consumer use cases and for more like hobbyist use cases, long context is great because you don't have to think about RAG. But it is the case that in these enterprise use cases, you need RAG even more because now you have a million PDFs or like 100 million
I
pages
mean,
of financial
yeah,
reports.
yeah, exactly. I think the other way to think about it is like when do you actually need like a search system? There, as long as we assume there will be some need for search, then I
Yeah,
think there will. A RAG is basically search.
exactly. I guess one question here is what are the advantages of these constrained workflows that you're talking about? And where do you see that going as models get better and better?
Yeah, it's a good question. I think I touched upon this. I think more people are actually building the constrained workflows right now, maybe just out of because it's like easier to think about. It's just a computer program where you add like a sprinkle in like an LLM call for a specific use case here and there. It's almost like a way to demonstrate like a POC of an agent for your boss. Um, I think as models get better, there will be more consolidated agent architectures that can do more things in a more general setting. The hesitation around fully adopting those is that historically so far those are harder to introduce like guardrails around and
Mhm.
then they might not actually give you back the results that you want. I do think though as models get better there will be more general architectures and actually I know we have a low level of abstraction and that's great for just like full customizability eventually, especially as you even get to like low code or like there will be a set of people that are totally fine creating agents and like a high level of abstraction with just like some of the core capabilities.
I guess this is a perfect transition because the next question is around, are you seeing any successful common patterns that these companies are having when it comes to scaling the number of agents that they're deploying?
I think, let's see, it's a good question. To be honest, not really. I'm going to fully caveat this by saying like a lot of the production customers that we work with are also like larger companies that typically take a little bit more time to figure out the right pieces of their stack. I think if you talk to an AI startup in San Francisco, I think it will be very different. I am seeing like emerging patterns around being able to actually do governance of agents. I think even from a VP or CIO level, like that's something that people are concerned about just being able to actually track what's going on and making sure everyone has full visibility into the set of agents. I think deployment maybe is just a piece of that, being able to serve it via an API. I think the higher level question is just like how do you actually track all these agents and make sure they're working well and that they have the right permissions attached to them.
I actually want to ask the third question first, which is you mentioned the need to extract data from unstructured sources into a standard schema. Do you tend to see these people using things like standard SQL instead of these more like NoSQL databases?
Yeah, there are for sure. I think, yeah, how do I say this? Yes, basically, there's a certain class of use cases around like document extraction where instead of like vector indexing on the semantics, it's more about normalizing the data in a certain structured format and then putting that into some sort of like data warehouse. in general, I think there'll be a need for both like structured and also like semantic search, and the agent should have access to both.
I see.
For an example, in manufacturing or like very like hard tech focused companies, you have these like technical data sheets and specs, and you need to extract out the data from those data sheets into some sort of like standardized format.
And then so maybe one last question before we wrap this up, just because I know running over where to go. How do you think about this agentic RAG system and whether or not it's worth the added complexity versus this like naive RAG?
I think most people, I think in terms of like value to the use case, like the value to the end user, I think more people are just doing agentic RAG. I think every default chat interface is effectively agentic in nature anyways. If you ask a question to O3, it basically does chain of thought under the hood now. I think that's almost like a baseline of expectation from the user. I think the issue with just doing naive RAG is that it, like the end user will inevitably ask questions where it's getting back not the right results or an incomplete result, and they won't be like super happy with it.
Let's also just do one more like live question before we wrap up, just because I'm sure some people have a more complex question to ask. Does anyone have any live questions before we jump back into the Slido?
Hey, Jerry, thank you for the talk. I had a question about where do you see the future of chunking going? I think I recall Gina creating a very complex regex function to parse text data, but it seems like a lot of the new chunking methods are using LLMs to chunk. And a follow-up to that is, what do you think about augmenting the chunking data that the LLM produces with a Raptor with possible questions that could be answered by this? Yeah, just the trend in that.
Yeah, that's a good question. It's interesting. This might be hypothesis, and I don't really know if it's true, but I'm just gonna say it anyways. I think a lot of chunking, like the need to like carefully tune chunking, is gonna go away because I think what actually matters is you can actually do a pretty simple chunking algorithm, like page level chunking. And then as long as you tag stuff with the right metadata, then you can solve the issue of having fragmented chunks. I illustrated a little bit of that in the notebook that I showed with dynamic section retrieval. But the idea is that you can start off with pretty basic chunks. Let's say you just retrieve pages from a document. And then as long as you can do a second pass retrieval to then expand that context to then include contiguous context within an entire section or a document, then I think you actually solve the issue of having fragmented chunks. I don't know if that makes sense. The other part is that as context windows get bigger, your top K can just increase and your chunk sizes can increase. So then the retrieval performance will just go up, or the synthesis performance will go up.
Gotcha. Nice. Yeah, so it seems like it's a good bet to test out LLM powered chunking.
Yeah, I think you can try out simple chunking first, and then as long as you tag it with the right metadata, you can always do a second pass like filtering after.
Gotcha. All right. Sounds good.
Let's do one last question with Christopher before we wrap up.
Hey, Jerry. I saw that you also offer on-premise deployments for Llama Cloud and Llama Parse. I was wondering what is your minimal business use case that you require in order to offer this? Because there are many clients smaller, but very interested in data privacy and all that stuff.
Yeah, it's probably a better fit for larger enterprises, and this is more a question around pricing and stuff. But I think we deploy within Kubernetes, anticipate kind of minimal document volume, and then hook up to some of your existing systems. It's typically offered for some of the larger enterprises with higher doc volumes. But yeah, happy to chat offline if there's interest.
Okay, cool. I would have one follow-up question, if I'm allowed to.
Yep.
So I saw you released a multimodal embedding model, the multilingual embedding model for.
Oh yeah.
And I was wondering, what is your experience? So how it compares to text-only embeddings, because you always have that option to basically turn a document into some sort of text. And I was wondering if the simpler variant, just use model, is better.
That's a good question. That was like a fun model we just released to the public. The honest answer is I don't really know yet. So I think we're running those benchmarks like right now. And I think if it ends up doing better than the text-based parsing, we're going to include both.
Okay, thank you.
I think that just gives us 2 more minutes and then we can just wrap up. Yeah, Jerry, thank you for sharing your knowledge and thank you for answering some of these questions. If you feel like there's any other good answers you have from the slides, I'm happy to receive them and then share them with the cohort after we publish the videos.
Yeah, no problem. I just feel free to share the slides. Let me know if there's any questions. I hope that was useful. And then if I didn't answer some of these questions, I know there's a few in the Slido. Just feel free to reach out. And then yeah, thanks for having me.
Sweet. Take care, everyone.